Hi, fifth graders. Thanks for joining me for our lesson 8-5 practice. We are doing representations of area to develop procedures. It was great work in class for this lesson. So hopefully if you're working along, you just wanted that extra practice and just wanted to join me for some fun, right? Some math fun. All right, let me share my screen with you. And here we go. This is what your page looks like. It is P77 and 78. Here we go. We are starting with, is this the right lesson? Yes. Okay. Sorry. For a second, I thought maybe I was on the wrong page. I think this is it. We're going to start with, of all the cookies in a cookie jar, 4/5 are oatmeal. Of the oatmeal cookies, 2/3 have nuts. What fraction of all the cookies in the cookie jar are oatmeal with nuts? I'm sorry, I'm still feeling like this does not follow our lesson today because we were doing area, but it's okay. We're still doing some work with fractions here. 4/5 are oatmeal. Of the oatmeal cookies, that's important to note, of the oatmeal cookies, 2/3 have nuts. So what fraction of all the cookies in the cookie jar are oatmeal with nuts? I don't know, I'm having a day here. Let me just make sure this was the right lesson from today. Oh boy. Okay. All right. It is looking like, yep, this is it. All right. Just want to make sure. I was feeling like there should be some area stuff going on, but we'll get to it. Okay. So 4/5 are oatmeal. I went 2/3 of the oatmeal cookies. So you'll remember, if we want to put this in order, I'm going to go over here. 2/3 of the oatmeal cookies are have nuts included. So I multiply across numerator times numerator, denominator times denominator. We could say 8/15 of all the cookies are oatmeal with nuts. Now, if you simplified that, you might have an equivalent fraction of what? Can we simplify that? Nope, we can't. That is simplest form right there. Okay, easy enough. Here we go. Now, this looks like what we did today, right? Okay. The dimensions of a patch are shown. 3/5 feet and 1/3 feet. What is the area of the patch? And we're going to use the square to help us. So 3/5, I'm going to divide 1, 2, 3, 4, 5. And I'm going to number those like I did in class, just to show I have 5 columns. I'm going to shade in 3 of them. So I'm just going to do that shading with my pencil here. In class, we used maybe some colored pencils, or we did a variety of lines or just shading. So whatever you prefer. And then that is 3/5 by 1/3. So I'm going to go across in thirds. And there's my rows of thirds. And I only have 1/3. So I'm going to color or shade over what I've already shaded a little bit. And we're going to see right here, I don't know if my shading is showing up very well, but right there where I made those X's, that's where I've shaded in twice. So you can see in our model, now we have 3/5 by 1/3. The equation that would go with it, 3/5 times 1/3, we could say that is 3/15 of a square foot. If you are doing the simplifying that we talked about in class, you might rewrite it like this and find that number 1 in disguise. And then in simplest form, another answer could be 1/5 square feet. Now, that does not show our model. We talked about this being our answer that shows our model. This would be in simplest form if you, I know lots of you have that in your brain and you like to do simplest form. So this is a reflection of the model. Here we're finding the products. So I have 7/8 times 5/7. If I multiply across numerator and then denominator, I would get 35/56. Now, you may have noticed the numerator and the denominator both have a 7. So that tells me that this could be simplified to 5/8. The numerator and denominator here can both be divided by 7 to give us a simpler answer, a simplified answer. Here we have 2/9 times 5/6. Again, multiply straight across, that would be 10/54. I'm looking, if I were to 2 times 5, my numerators, that's 6. I want that to be renamed as a 2 times 3 times 9. And then I can get rid of that number 1 in disguise. And that tells me that this answer has an equivalent fraction of 5/27. They can both be divided by 2. Whatever we use as our number 1 in disguise, that tells us what that first answer could be divided by. And then we have 8/11 times 3/4. Again, that could be 24/44. Or looking at my numerators and denominators, I see a 4 and an 8. I'm going to rename that 8 as 4 times 2. And then I still have my times 3. And I'm going to do 4 times 11 for the denominator. 24/44 can be divided by 4. And then we would get a simplified answer of 6/11 right there. Okay. Number 6, a large sandwich at a store is 11/12 of a foot long. A small sandwich is 3/4 the size of a large sandwich. What is the length in feet of a small sandwich? It is 3/4 of 11/12. So if I do that work, I would get 33/48. Now, that's a fine answer. If you like simplest form, you could look at 3 and 12 work together. So down here, I'm going to rewrite that 3 times 11. I'm going to rename the 12 as 3 times 4, and I still have another times 4. So 3 times 11 is representing the denominator of 12. And then I had another denominator of 4. There's our number 1 in disguise. 33/48 can be divided by 3, and we would get 11/16. And we're talking about of a foot. So I'm going to make sure I label it. All right. If I look at the test prep, Matilda has a marble weighing 1/6 of an ounce. Another marble of the same size has a chip in it. She weighs the chipped marble and finds it weighs 3/4 of the amount of the unchipped marble weights. How much does the chipped marble weigh? So a marble is 1/6 of an ounce. The other marble has a chip, like a broken piece out of it. That's 3/4 of the unchipped. So I would have 3/4 of 1/6. And when I do that work, I would get 3/24. And I am talking about ounces. That would be letter B. Of the vegetables grown on a farm, 2/3 are green vegetables. Of all the green vegetables, 7/8 are ready to be picked. What fraction of the vegetables are green and ready to be picked? So 2/3 are green. Of all the vegetables, 7/8 are ready to be picked. So 7/8 of the 2/3 would equal 14/24. Now to the side, I see a 2 and an 8. So I know I can keep 7 times 2 for my numerator. I'm going to move the 3 over and I'm going to rename the 8 as 2 times 4. So there's our number 1. 14 and 24 can be divided by 2. So we would have 7/12 as our final answer of the vegetables that are green and ready to be picked. All right. 14/24 would be a fine equivalent fraction. Just know you can start simplifying if you're ready to do that. A rectangle has dimensions of 7/10 of a meter and 3/5 of a meter. You want to find the area of the rectangle. If you use an area model to help you find the area, which statements are about the area model are true? So 7/10 of a meter, 3/5 of a meter. Well, in order to answer this, I'm going to actually draw out my model so that I can compare it to the choices. I have 7/10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are my 10 columns, and it looks like we have 7 of those. So I'm going to lightly shade in 7. And then I have 3/5. 1, 2, 3, 4, 5. Those are my rows. And I have 3 rows. So I'm going to go all the way across 3 of those rows. And then I'm going to see, let's see, we had 3 and 7. So kind of hard to see. I'm going to try to show you here where they overlapped. We had 7 and 3. So I'm going to just block out. Maybe the X's will help you see it better. There's where we overlapped. So will there be a total of 21 smaller rectangles? Now, if I have 10 by 5, I have more than 21 smaller rectangles. There will be a total of 50 smaller rectangles. 10 by 5, yes, that would be 50. I'll take that one. 21 of the smaller rectangles will be shaded twice. 7 by 3, is that 21? That I shaded twice. I put the X's on there to help us see it. That's true. 50 of the smaller rectangles will be shaded twice. Well, nope, I just said that 21, so that's no good. The area will be 10/15 square meters. The area here would actually be 21/50 square meters, so that's not good either. All right, looks like B and C there. Alfonso multiplies 5/12 and another fraction. If the product is 15/48, what is the other fraction? 5/12 times something equals 15/48. Well, if I'm multiplying across, 5 times what would be 15? 5 times 3. 12 times what would be 48? 12 times 4. So our answer would be 3/4. Ooh, a little spiral review. Order of operations and fractions. I need to do this work first, but I need a common denominator. I'm going to go with 24ths. So that would be 2 and 9/24 plus 1 and 8/24. So right there, I would have 3 and 17/24. Oh, hold the phone. Did you catch what I just caught? Look what we could do. 6 and 5/8 plus 2 and 3/8. I'm going to do that first. Plus 1 and 4/12. I went straight for order of operations, but we learned about doing that associative property, right? I'm going to do these first. So now I'm going to go up here. I have 8 and 8/8. Ah, that equals 9 plus 1 and 4/12. 10 and 4/12 would be a beautiful answer. You could simplify it to 10 and 1/3. Oh, I'm so glad I remembered that. That made it so much easier. Oh, I hope you caught that. Okay, last one. I have subtracting in parentheses and then multiplying. So 33 minus 8 would be 25 times 9 minus 6 would be 3. So we are going to get an answer of 75. That is all. How did you do? Did you stop and do the test prep before me, or did you stick with me? I hope you did well. Bring any questions you have to class and let me know how it went for you. I really appreciate those of you that join me for these meetings and work through the extra workbook pages. So good job for you. Way to take control of your education. I'll see you in class next time.